it has an effect on the audio. I'm not sure. Yeah, let's do flight mode. Can't hurt. Just for safety. And so, yeah, sorry about the confusion. As usual, it was I was the one who was confused, but they had scheduled us in a room without Maya, and so yeah, we managed to trade rooms, so that's good. We're here September 24th. We will be looking at polygonal subdividing today, which is, you probably tried it. If you press number 3 on a model, it turns into a blob. That is subdividing. So we're going to look at what it is and how we can use edges and the placement of edges to sort of define the curvature. So for the primitive city, I managed to go in there and for your deliveries, and I pressed 1 as the grade. Did you see that? So the highest score you could potentially get is 1. So if you got a 1, that's awesome. If you got 0, then I wrote just a little comment on like what you should add. Yeah, so if it's nothing, then just I put a comment in there. Okay, so that worked. Good. I wasn't sure if that worked, but it seemed to have worked. So as far as the deliveries and so forth, speaking of the deadlines, so I don't really care. It's really just up to you. If you do it within the deadline, I highly suggest you do it within the deadline, because if you don't, you're probably going to have some issues, like I said initially, following along in the course, right? So what we're doing today, if you didn't do the kitchen furniture, maybe you'll have a much harder time following along. And that's really true. So, and for this course, it's a 5-credit course, so it's kind of a small course, but it's stretched over a semester, right? So that's why there's also more time in between the sessions for you to be working. Well, I think that's a good thing. So, there's more time on your own, which also means that these deadlines should be considered doable, in my opinion. So if some of you did not deliver and you're wondering if it's gonna, if that's a problem, it's not really a problem to me. It might be a problem to you. I hope not. So you need to get busy then, But all of that just to say that in the end, after all of this, you will resubmit everything. Not to Canvas, but to another system called Inspira. Have you tried this yet? Right, okay, so that's fine. So you'll be given that information from the student services. It's a different system. You upload all these PDFs to Inspira, is what it's called. Okay, so that's the official hand-in. That also means you can, I don't care, you can just make any changes you want, make it, if you want to improve on these earlier assignments, like I showed you in the first session, they don't really count too much in your final grade anyways. But if you find that, yeah, I have some time, I might go in here and perfect the written report or something, you can do that. And then you deliver everything by December 6th. Okay? Right. So are there any questions, concerns? Has anyone started on the optional one? Does anyone want to do the optional one? Yes? Some people. There's an optional one, which is, yeah, just make whatever you want, basically. If you do the optional one, it cannot hurt your grade. It can only benefit your grade. Yep. Yeah, just say that you made it in this class. Yeah, there would be no way for me to, or for anyone to. But you need to just document the process. So that's the important thing. So if you see, I did this, then I did this, then I did. If you only submit a finished model, that could potentially be kind of spooky because it raises all these concerns if it's really your model, right? So you don't want to do that. Yeah. Who? Someone had another question. Yeah. 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 But there can be too much. It's not that interesting. If you're like, yeah, I did this, then I pulled that vertex over there, you know, then yeah, yeah. You have to use your own judgment. It's basically you're showing what you did, you're showing the process, you're showing the iterations, and it's like you're giving an insight into the process without the person having to open your Maya file, essentially, right? But yeah, there's definitely there can be too much. I'd rather have too much than too little, probably. All right. So, have you gotten to know Luai? Yes? Good. Yeah, blah, blah, blah. Let's just get started. Maya. So, subdividing. So we make, let me get rid of some of these. Where's that? UI element. Yeah. So we have a cube, and we press 3. It turns into more or less a sphere. You probably tried this. And like we did last time, we tried to like unmerge one of the vertices to see that that would cause funny things happen in the subdivision. It's no longer like a manifold or yeah, where all the vertices are merged. If all the vertices are merged, you have a consistent, technically solid mesh. If you press 3, this should happen. It will be more smooth. So let's see, like technically, what really happens. So if we go and press Control A to open up the attribute editor. I'm just going to close the door. We have something called smooth mesh. So that's really what happens. So if you pay attention there, you'll see a number, the number 2. That's the number of subdivisions. So if I press 1, now it's only been subdivided once. So literally what happens is that each time you subdivide, it will not only double, but it will quadruple the poly count, and it will also introduce this curvature, right? There is an alternative to this, or in other words, we have something called smooth, mesh smooth. This is technically exactly the same operation. So if we go into smooth options, you can see that here are the division levels. So there we see Catmull's name. Like remember Ed Catmull kind of wrote his PhD on subdivisions. 2 subdivision levels apply. Let me undo that. Try 1 apply. So you can see that wherever there was a polygon, now there are 4 polygons. And we have a smoother result. So that's literally exactly the same thing you're looking at over here when we do the smooth mesh preview. That's what Maya calls it. If we set this to 1, you're looking at technically exactly the same thing. It doesn't look like it currently from the display, but it is technically exactly the same thing. The only difference is that when you use the smooth mesh preview, we can go back and forth. So if I press 1, now I'm back. We can't do that here. Well, I can just undo it and then do it again. But that becomes very tedious. So that's why, of course, we just want to use number 3. But there are some very useful instances where we can implement the smooth operation in the workflow. So sort of we're going to try to wrap our heads around that today. But initially, just to show you that that's literally what happens. It's just that you quadruple the poly count per division level, and you get this smooth result. That also means that it quickly becomes very heavy. It's an exponential growth, right? You're quadrupling every time. So only a few iterations, you get a very dense mesh. Let's try that with the cube. So if we do, oh, let me open up the heads-up display poly count. So see faces. This is the currently selected one. It has 6 faces. If I go smooth, and I can do like 4 levels. Very quickly, it gets kind of heavy. 1500 or 8 levels. This might make Maya unhappy. Yeah. No. So 7. No. No. Okay. 6. Yes. So we have 24,000. And of course, that gives you a very smooth, very nice curvature. And that's what you need, right? If you're doing a very high, very nice render and you have smooth surfaces. The way we're working with this is that we add polys to the contours. So technically, it's exactly the same thing. It's just now we have a bunch of these polys, a bunch of vertices. All right, so let's analyze a little bit what happens to the curvature. So we've seen that, okay, so it quadruples. Let's talk about the curvature. Press number 3. What do you think is deciding that curvature? What do we have to work with? The vertices. The placement of the vertices is what actually is sort of defining the curvature. And to make that point, we can try to draw a curve. So here we have some curve tools. You can also be modeling with curves and using surfaces, which is we will not be doing right now, but it's another approach. We will look at that later. But CV curve tool just stands for control vertex. CV curve. This works in the orthographic viewpoint. So if I'm over here, so I'm going to draw a curve. So you start placing a point, you place another point, and you place a third point. So you need 4, I guess. But essentially, you need 3 points to define the curvature. So you see these 3 points, 1, 2, 3, they're placed far apart, so you get this result. If I draw, let's see, let me just complete that one. So obviously then if I draw another one, and I'm going to place some points closer together down there and finish it up here, that's the result. So this is sort of what we're looking at here if I press 3. The curvature is derived from the placement of these vertices. So 1, 2, 3, they're spaced far apart. The curvature becomes more smooth, just like with the curve itself. The control vertices are placed far apart. Here we have 3 vertices, in this case control vertices in the curve, placed close together. So obviously if we're in here, it will look smooth, but out here it will not. So how can we then control the curvature using that mindset with a cube? Well, we can insert more vertices. In other words, insert more edge loops in this case. So if we try that, I'm just going to go. So that's shift right click, you have this, oops. Shift right click, you have insert edge loop right there. Last time we made a shelf, which seems to be gone. When you make a shelf, will it stay on your user? It does not? Mixed feedback. Okay. Hmm. Yeah. So on the labs, it should follow you around at least. So insert edge loop, Control Shift click. I can add that to my little shelf. So here then, if I start placing an edge loop here, if I look at this cube, I'm analyzing it from this view. So 1, 2, 1, 2, 3, 4. But you can see that still this curvature will be defined by these three vertices, which are fairly far apart. Let's just try it. So if I press number 3, that's what happens. There's an intermediate way. You can press number 2. That will actually show the what we call the base mesh, or the cage, the poly cage, which is deriving the curvature. In other words, just the basic model. You can see it at the same time as you see the smooth result. Then I go to edge mode. I can double click this edge and move it around, and I can sort of see in real time how is that updating the subdivision. I can also be just in number 3 and keep working over here, but you have to be a little bit careful with that, because if I just go like that, that looks nice, but you've actually arrived at a solution that's not technically okay. If I press number 1, you see that I've just kind of pushed that out of bounds. So I can't do that. So be a little bit mindful when you're modeling that you're actually observing the base mesh, you're observing the simple form also. Okay, so let me just try to add some more edge loops. So if I place one this way, we can see that now I actually have 1, 2, 3 vertices close together. That will create that sharp curvature on that corner, on that edge. So press number 3, you see this is what happens. So if I went around and I did that, whoops, here, oh, yep, there, there. So now you can see all the corners are defined by 3 edge loops. This is the result. So that's how we can retain that shape. It's no longer a blob, it's just a cube with a little more rounded edges. So that happens to be very similar to doing a bevel, right? As we were doing bevel last time. So I do bevel, and I can go down to the bevel operation, and I'll do 2 segments. I can turn the fraction a little bit down. I can also turn off chamfer, let's see, off. So then literally that's the same solution. So if you wanted to have, like, if in this case it's just a cube and you want to have all those edges just defined, you could do a bevel. So then I could press number 3 on that and have that result. It's a standard polygonal mesh. It just has edges defining all the corners. So does that make sense? Yes. Okay. Yes, but of course there's another reason to use bevel, just to not get confused, but I'm just going to mention it. It's like we were doing last time, right? We're just using bevel here, and I can do 2 segments, and that's it. I don't have to subdivide it. It looks kind of nice. If you're not subdividing it, you're saving poly count, right? If I'm subdividing it, I'm quadrupling the poly count per division. So if this looks okay, which in many cases it can, if you only want like smooth edges, for instance, in hard, like for a table, you don't really have to go in there and add a lot of, so we call these creasing edges, the edges that are just inserted just to retain the curvature. You wouldn't necessarily have to implement a lot of creasing edges to subdivide it if it's something like a table. It could be very simple. You just keep the poly count fairly low, and then you just do the bevel on all the corners. Now the reason this looks smooth is just that the bevel operation actually smooths the normals, because it figures that, okay, you're beveling, you probably want smooth looking corners. So I can go, I don't know, do you remember normals? I think we talked about it a little bit. Under mesh display, we have something called normals. So here we have harden edge and soften edge. So if I go harden edge, you can see now it turns it back to more of that crude looking, we can see more the polys. Soften edge will kind of average out the result. And you see the same thing for a sphere, like the polygonal primitive. Initially, this is set to smooth. If I set it to harden, it will look like that. So that, just to understand, there are different purposes of beveling, but if you could also use it to quickly insert creasing edges for something like this, if you were meaning to subdivide it. Right? Makes sense so far? Yes. Because, I mean, whether or not you're subdividing something just depends on the look. So let's say I'm like building something here. I'm going to extrude it, pull this out, extrude again, pull down, something like that, and then subdivide it. Now we have this shape. That is something that I would need to subdivide, right? Because I have this beautiful transition, whatever this is, right? And I want to retain those hard edges. In that case, bevel would not suffice. I'm just beveling for the purposes of having easily placed creasing edges, and then I'm continuing building my whatever this is. And then this could be sort of the initial stages of something, whatever it is that you're doing, just building blocks. And then maybe at some point you want to commit to this shape. This is the mindset I'd like you to get into. So you're building simple things. You can use very basic models. Just make sure that they're technically solid. You don't, okay, so we approach this starting off with the simple shapes, with the larger shapes. And then we're gradually kind of making them more advanced. So if your mindset is initially, okay, I'm gonna build the most amazing thing here, so I need a lot of polys probably. Just gonna go like that. And then you start building, that's very inefficient, right? Because you're dealing with a lot of vertices, there's gonna be a lot of pushing around, and it's just a mess to work with. If you can arrive at very simple shapes, a more elegant solution, and then you try to subdivide, okay, that's nice. But now I wanna commit to that shape. Let's say that I wanna add some more details over here. How can we commit to the shape? How can I add more details? In other words, I want this to be the new starting point where I can start building more on top of this model, or maybe extruding more. Any suggestions? If I wanted this model to have this as its new kind of starting point, when I press number 1, I don't want it to no longer to go back to this very simple initial stage. Yeah? Yes. Yes, just use smooth. Exactly. We can just use smooth. So then I copy it over there and I push it over there. So I treat Maya just like a workbench. So if I have something there I'd like to keep, whenever I have an initial stage figured out, I would definitely make sure to copy it. So I copy it and push it over there. There's the initial starting point. And then, you just use smooth. So then I can go delete history. I can go freeze transformations. Boom, boom. So that's a very nice habit to do. And then we just smooth it. Oh, now it's set to that incredibly large. Yeah. Okay. Let me undo that. That would not be necessary. And I just like 1, So you want to keep things kind of manageable. So if I press number 3 on these two right now, what do you think they're going to look like? How are they going to differ? Yeah, maybe. Let's try. Press number 3 on both of them, and you can see that, yeah, it's very similar. Obviously, this one will have more polys. The poly count is higher. But since I haven't really, this still retains the basic curvature. So it's not going to be a whole lot of a difference. Just to drive that point home, if I do that, and I copy that, and I press smooth, now I'm sort of committing to that shape. If I press 3 on both of these, they're going to look pretty similar. So when you're building models, when you're arriving at more curved forms, you can start out very simple, like very cubic, such as this. It's very cubic. So yeah, so next session, or not the one after that, we're going to start UV mapping, which is just making a flat version of the model. You don't want this to be the lowest stage. This is simply a building stage. Even in the lowest stage, which this could be a nice kind of maybe a low poly version of this, even if you meant to subdivide it. It's just that I want the curvature. I want the curvature to also be retained in the low poly version. Okay, you can see over here, the curvature is not retained in the low poly version. I can only see it if I press 3. I want that curvature to be contained in the low poly version. In other words, I would not UV map this model. I would UV map something like this. It could be more low poly, but if you can get away with having those few polys at least defining the curvature, I would opt for that. Okay, so the purpose here then would be, maybe I can make a copy of that again, and then I push these over. So if you do this, just make a habit of making a copy whenever you reach kind of a milestone or whatever it is that you're doing. Then you have it right there, and it's also kind of nice for your report and everything because you can easily show a progression. Yeah, so maybe here, purpose for doing that could be, I wanted to keep. So if I shift click here, I can select this face path. Maybe I wanted to do something like that. Just keep adding things. Oh yeah. Excellent. And then, right, so basically I now have the opportunity to do that. I can go, well, they've added this nice feature now called circularize, which will turn this into more of a circular. We used to add a cylinder and then we'd snap these vertices to the cylinder, but now they've added the circularize also in Maya, which is nice. And then I can build it like that. So you get the idea. If I want more complex shapes, you don't start off thinking about this piece. You kind of have to approach it in stages. So you think about the large shapes. You establish the overall forms, the overall contours, and just get the shapes right. And then you can worry about the details. Like if you want to add, I could even go further than this, right? So that would be the new starting point, and I could make a copy of this and then move these over. You get the idea. And then I can okay, smooth that one. Now I have even more fidelity if I wanted to do some really small things, whatever that would be. Is this not symmetrical? Doesn't seem to be. Anyways. Yay. So there it is. Beautiful. So that's kind of the basics of how this works with the edge loops defining the curvature, and then you can gradually start building complex shapes. Any questions? So I mean, yeah, yeah. Hmm. Yes. So you would UV map whichever version of the model is the lowest. Hmm. So the only thing I'm saying is that you probably don't want to UV map if you're intending to subdivide, right? If you're intending to subdivide it. If you're not intending to subdivide it, okay, then you get what you get, right? The point is, if you're intending to subdivide it, you don't want to UV map a version which does not contain the curvature at all, right? Because you will get a lot of, it's unpredictable. The textures will not apply nicely, and yeah. Hmm. Yeah. Yes, you're absolutely right. So it used to be the case that you would, for creatures or characters, that you'd start out like this, like you start out poly modeling and building everything. And most often from like a very defined concept art. So you would have like a front view, side view, and then building the initial stages of the character or creature would be kind of a engineering task, right? So you'd have to think about the topology and everything all at once. But now, yeah, nowadays you don't do that. So yeah, for that workflow, like most people use ZBrush as a digital sculpting application, and then yeah, you can go just crazy, just however many polys you want. You don't think about the technicalities at all, and then you can output like very, very low poly models if you want, and just bake everything down as normal maps. Also for VFX, like you can't just take that, you know, 80 million poly character from ZBrush and put it in Arnold and hit render. You can, but you don't want to. So then you'd rather bake displacement maps for those. So like regardless of whether you're building something for a game or a movie these days, it doesn't matter. So you're absolutely right. But in order to do that, in order to be able to uh, retopologize something, is what you call it when you have a high poly creature or something sculpted, and then you want to make this in-game mesh. In order to do that and to understand whatever it is that you're doing, you have to understand polygons, and you have to understand UVs, because essentially in the end, that's what you'll be dealing with, right? So we will not be approaching things that way in this course, but in CGArt 2, if whoever wants to take that, that's all about, it's kind of in reverse. So we start off with the art, and then you get back to this later, right, essentially. Yeah. Yeah. Well, we can try it. Yeah, certainly, if you want. It's pretty simple. I mean, yeah, it's pretty simple. If you have, as long as you have good UVs, and you have a nice color map, making an emissive map, like to have things glow or self-illuminate in the game engine, is very simple. Like technically very simple. It's just a map that defines where things should be glowing, right? So yeah, we can try that. The point is, once you master the polys and UVs and like you get it, the next taking that further is kind of, it's fun, you know, painting a nice emissive map and work. So you're also getting into Photoshop then, right now, I hope, in some other classes, some of you. Okay. Well, you should probably also start looking a little bit at Photoshop, like because in this class, like I said, it's like we're staring at a bunch of gray, boring cubes. It's but we have to learn that. Yep. Yeah. So okay. So some people like this PSD link that you can actually establish in Maya, but it's very unpredictable. So I never use that because first of all, you don't need it. It's just if the link worked, okay, maybe, but I don't see the point. So I would just not use the PSD networks because a lot of the blending modes you could do in Photoshop, they don't transfer predictably to Maya. Yeah, so yeah, it could be anything. It could like literally, it could be JPEGs, PNGs, Targas, or TIFFs. So a lot of people also think that if you're doing CG, you have to use like Targas or TIFFs, which are uncompressed. But you don't. You can use PNGs, JPEGs. You will not be able to tell the difference. Except for like displacement maps or normal maps, you can consider larger formats. Like EXR files. Have you heard of that? EXR, which is the 32-bit format, would be more for displacement mapping. Yeah, so you're asking a lot of advanced questions. That's good. Yeah. So anyways, uh, good. Any other questions? So this is all about like getting that confidence when dealing with a mesh because it's useful for anything that you will be doing, I think, in CG. Other things? Yeah. Okay, merging two objects. Let's open up the outliner. The question is, how do you merge two objects? Okay, so just why would you merge two objects? Okay, I see what you're saying. So, like you want to sort of be working on one portion of the model separately and then merge it together later? Hmm. Hmm. Okay. So, all right. So you build the half and then you try to mirror it. Essentially, then in that case, okay, let's just use a cube again. So we'll smooth it. So whenever you're building things, just make it a habit that the z-axis is the front, so that that blue axis is the front. And then you should also have a dividing line, like that would be then at 0x, right? So then as long as this is set up correctly and all these vertices are exactly at 0, so sometimes, that could be over there a little bit, or this could be over there. That could cause some issues. So you need to have a dividing line, and you need to make sure that all these vertices are at 0x. There is a little thing up here, which is hidden for some reason. Then I can go to the move tool and press 0, and it should move all the vertices to 0x. I'm just going to, sometimes that doesn't work. Then I could just do it manually. I can move everything. So I hold X and I snap this vertex to the grid. Now they're on 0. I can also scale them towards each other. So then I can scale in X, and that will gradually kind of scale the vertices towards each other. And then I can move all of these, and I can hold X and snap. You just need to make sure they're really aligned. And then it should work to do mirror. First of all, I'm going to delete history. And then mirror. and just check the axis. So right now we're going to be mirroring with the x-axis, so it should be set to plus x, apply. So that should initially merge the vertices. So again, if you open up the heads-up display poly count, I like just having that open, so then I can initially just see if I select a vert, see, yeah, that's 1. Right. But if for whatever reason that didn't work and the vertices did not get merged, let me just detach component. I can detach. Now that's detached. If I subdivide it, it will cause strange things. And I can see that, yeah, now there are 4 vertices there because we have 4 edges coming in. And then I just merge it. So edit mesh, merge. That should work. So you could also have, I mean, there's a whole bunch of things that could happen. Maybe you have some internal faces. That often happens. So if you forgot to delete some faces that would be stuck in the middle. I think maybe now they fixed that. Let's try to mirror this. Yeah, so I think the new mirror tool is kind of taking care of that. So it should work, but yeah. But so a lot of these, a lot of what we're doing is causing failure to happen. So that's a good thing, right? You have to look at failure as great. Like you want to fail as often as you can with these things, because then you can discover something interesting, right? So this is all about failing. Failure is good, right? Yes. So so you could try like a fun little thing, just make whatever, keep extruding. I don't know. My advice right now would be not to necessarily worry too much. Like make something fun. Like I'm just gonna. I'm just extruding. Keep subdividing. See what it looks like. Oh, that's interesting. Oh, awesome. And then that's the first stage. I'm just sort of extruding and checking it out. And then I'll copy that. This is the initial stage. I'll smooth it. I'm committing to the shape. Yes, now I have some more polys to work with. Let's make a windshield. I can click that little icon to change the manipulator handle on the extrude. I can hold control and scale here, and it will scale in the other 2 axes. There is a way to activate symmetry on the move tool if you want to. You can hold W, and you can hold left mouse button, click and hold, and you can activate symmetry. So symmetry, you see now it will be across the x-axis, which is typically, oh, so now I just messed up because this is not aligned correctly. So the z-axis should be the front. So I'm just going to rotate this. I can hold E and hold left mouse button, and I can turn on discrete rotate. I'm just going to rotate it like that, not like that, like that. So discrete rotate, it just rotates it in increments. There we go, delete history, freeze transformations. And since my move tool now, if I go to vertex mode, it's now symmetrical across the x-axis. So that's nice. Just remember to turn it off when you don't want that anymore, because it can cause artifacts when you're working. So W, left mouse button, click and hold, I can turn symmetry off again. So then I'll select all that. Yeah, extrude. Extrude once again, push it in. Extrude once again, push it in. If I extrude a couple of times, you can see that I'm leaving behind, well, I should have left behind another one, but right here, see, I'm kind of establishing this, this kind of edge with 3 edge loops. In other words, it will retain that curvature, right? Yay. And of course, we need some wings. So typically, I would just not worry too much about making this so symmetrical all at once. Like I would just make sure to have a dividing line. This has a dividing line. Then I would just delete half of it because I know that I'm just going to mirror it. And then we can make a wing. Let's, where, yeah, maybe here. So I can just, you know, make these vertices just do whatever you want them to do. You don't have to be afraid of manipulating the vertices, just moving things around within reason. So what I don't want to do is like that. You know, so you can see that's not a happy mesh. It's unhappy. So that's the thing. You know, if you push things too far, you can see that it's not comfortable. Things need to flow. There needs to be a nice, what we call edge flow. You know, you can feel this. Then I extrude, and I hold control. And I extrude again, and I extrude out, and I extrude out. Yeah. Let me try that. Wow. Ooh. That's nice. I like it. Thank you. So then I can copy that, move it over there. Now I'll mirror it. Where's mirror? There. So, awesome. Maybe I now need to commit to this shape. So I'll smooth it. Now I have more to work with. So if I want to have some more like intricate little window here. And again, I just have to like, don't be afraid to move these around. This is what I have to work with, these vertices. I'm just forming this. I'm kind of picturing a little window here. Oh no, let's make a door actually. That would be more fun to do. So again, I'm picturing kind of where I want the door. So I want the door here, kind of a little hatch. The pilot to be able to get out. That makes sense. Yes, I'm just forming that. So you get the idea. So here I've kind of formed it. And maybe, yeah, that's it. That's going to be the door. So, and it's a small door. It's getting very small. That's okay. So then push that in, push that in. This is sort of defining the thickness. So if I smooth, okay, so there's the opening. So how do I make a door? That will be a separate object, right? So this is also you have to get used to, like what needs to be a part of the same mesh and what can be a separate mesh. So the mindset is always, how would this thing be constructed, right? That not only for something as obvious as a door, but also in anything. If you can have separate objects, it's easier to build. It will be more technically correct. And everything's just easier. It will be easier to UV map. So, but how can I make a door fit in that little space? Does anyone have a suggestion? How to door? Yes? 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 Yes. So use the existing geometry. So you're suggesting that I'm going to extract them. So I can go like that, And there's a feature here called, what is it, extract, separate? Yeah, where is it? Oh, there, yeah, you're right. So extract, that will separate them into two different meshes. Then I would have to delete history. Yeah, I can do that. Perfect, yes, good. Mhm. Is there another way, like a quick way? So I can copy the thing and just go like that. And then I just go like that. I need these. And then I'll shift select the rest and delete them. Yeah, but your thinking is good. Then I can just delete those. And now if I press 0, it will just pop back because I did freeze the transformations, right? And then I can worry about this little piece as a separate object. Um, so we should talk a little bit about like how to approach subdivision models from planes, because that's a kind of a powerful thing. Maybe we should take a little break, like take 10 minutes. And then we'll talk about working with planes a little bit. Okay, all right. All right, let's carry on. We'll wrap up today, and I'll talk just a little bit about how you can approach subdivision then from planes. Often starting from planes is kind of beneficial. You can work very efficiently because you don't have to deal with the thickness when establishing just the primary curvature of things. So let's just finish this first. So we have this door. If you select something in Maya and you press Shift I, you can isolate that object. You can, very quickly. If you select nothing, Shift I, you will isolate nothing. If I only want to be working on this, Shift I. This is a nice little trick. If I double click, it will select the entire edge path or the edge loop around the object. And I hit Control E to extrude. Then we have these options. We have thickness, which goes that way. We have offset. Offset is nice, but I don't need it to be that aggressive, so maybe I could do like 0.02, just a little bit offset. So you can see what it actually does is that it will create a nice kind of face path all the way around that geometry, right? Very quickly, which otherwise would be kind of hard to arrive at. But since I already had this, I could just quickly extrude the entire outer edge path, or the contour edges, just out. And then, since this is currently in object mode, I can actually just extrude this as a plane and drag this out. Now I have thickness. And there's the model, and maybe I could then also introduce an edge loop if I wanted to, going along this way to establish the curvature along here and also here. So if I try to subdivide that, it will look like that. So let's Shift I, let's see if that will sort of, so I can move it over here, and now I have that little hatch or whatever. It's not perfect, but I could tweak that and make it a little bit better. So, you'd probably want that tiny little bit of, let me center the pivot. So there we have a completely separate object. I can just treat that independently, make that perfect, just the way I want. So I probably still want to commit to that shape. Or it's okay. If I wanted to, the point here is just that I could easily build that from this simple starting point. And this is a plane. It's planar. It has no thickness. So the first thing I did, select the edge path, extrude, did a little bit of offset, so 0.02, for instance, and then I can extrude this entire thing in object mode to create the thickness, and then subdivide it. So that's very efficient because I already have those little polys there. I'm working with planes. And so uh, let's see, let's try one more thing. Well, okay. Um, so I'm back to that plane, but I could do a smooth. So if I wanted to work even a little bit more in the planar mode, let's say I wanted to carve out a little window or something. And again, you just make the vertices behave the way you want, right? Just grab the vertices are what you're working with. So if you kind of have to get used to customizing the model the way you want. So here I've established this little opening that could be kind of a little window or something. And if I wanted to create this opening, I can actually just delete those. Oops, now there's something funky with my model. Oh, there is thickness in here somehow. Those are little polys. That's not nice. Go away. I don't know how that happened. Anyways, point is, this is also a nice way to make openings in things because this is still just a plane. I can extrude it, and there I have the opening. Oh, oh, something funky with my mesh. Let's see. Go away. I'm gonna try this again. I only need let's see if this will work. Yeah. And again, if I wanted to keep that curvature, I could do the same little thing where kind of what we did initially when I extruded the outer edge path out to establish a contour kind of like this thing, what I did initially. I can do that here. So if I double click, shift double click this, it will select this face path, and then I can extrude that inward using thickness or offset. Oh. 0.01. So 0.01. Oh, we have not really talked about scale yet. Let's do that next time. So now I'm establishing that edge. So you can see how you can arrive at pretty complex shapes very quickly, and it's quite elegant because you're not dealing with the thickness before you have to, sort of. There would be less elegant solutions to arrive at this, and you could do that. I mean, there's no right or wrong, but I would certainly, today, I would want you to experiment with also with planar approaches. So you start off with a plane, and then you have a question. Yeah, okay, yeah, so yeah, yes. Um, yeah, so next time, I think it would be nice if some of you have some issues with your models. You could upload them to the server, and then we could meet here for the lecture. Maybe it's in the other room. I don't know. We'll see what happens, wherever it is scheduled. And then the plan is that we'll just look at some of your models and try to figure out like what went wrong. So again, this is all about failure. The failure is good. You do want to be failing right now so that we can discover interesting things. Right? If there are no failures, this class would be quite boring. Yeah. So, so that's the plan next time, is just this kind of troubleshooting thing. But then I was thinking on the lab that, yeah, we'd build like the teapot and all of that. Because then we can use a contour curve and then we'll just use like a surface revolve. So we'll approach it a little bit more differently, where we're starting out with surfaces and not polys, and then we'll convert it to polys essentially. But it'll be a little bit more advanced because we're gonna then, like for the Utah teapot, like the original teapot we looked at, you could essentially just tuck the handle in as a separate mesh, and it will kind of look like it's a part of the teapot. But we're gonna actually build it so that it's literally a part of the same mesh. So that if you wanted to 3D print it, or let's say whatever you want to do with it, it's actually a functional mesh. Then you would have to probably approach it in two separate operations, so that you think about the handle, the spout, and in different kind of operations, and then you merge things together, kind of. So next week, again, it will be a little bit more advanced in terms of like working with meshes. But yeah, so does this make sense? Then, that's how you can approach this, and this could be, that's a little thing. Yay. So the only thing we did there was to copy the object and just say, hey, can I use some of these other existing polys as a starting point for this new little piece, essentially. Yeah. Oh, I didn't really save this. So again, just make a habit of working out of a Maya project. So set a project window. Are you working towards the server, or server? You are using the server? Okay. So that's the Maya project folder, and then I'll save this. Yeah. So then I could start out with a plane. Just 0 divisions, or 1. Just a standard plane. And just to show that this is actually what you're doing when you're building. You are essentially drawing a curve. It's the same thing. So just to kind of show that point, if I just make this plane and I keep extruding, now I'm just extruding edges, right? Just extruding edges, it will leave us with more polys, right? And I press number 3, and there we have essentially a curve. So if I go to the front view and I go to vertex mode, the curvature is based on the placement of these vertices. It's literally the same thing if we went to curve tools, CV curve tool, which we'll be doing next time when we're building the teapot on the lab. But I can place these control vertices, which will control the curvature, right? So it's curvature defined by vertices in both cases. So that actually makes this kind of a powerful approach, because you can arrive at pretty complex shapes very elegantly. So if I just keep, like, let's say I wanted to twist this extrude, so I keep going. And you could use like various deformers and things like that. You can use like a lattice and twist the lattice, or wrap the deformer wire. We'll be experimenting a little bit with those. But I can also just manually go in here and tweak this. Let's say I want like this funky shape. So you can see that it's just, this would be trickier if I have to deal with the thickness also. But here there's no thickness, it's just a planar model. And then I'll use the same little trick. Okay, I pressed number 3, see what that looks like. So this, it doesn't represent anything, it's just kind of a wacky shape. But I can now make a thickness and have a very uniform thickness throughout the object, which would otherwise be kind of difficult to achieve. Like if you started out with thickness and then trying, you know. Anyways, so quickly, what I'll do, I'll just double click the entire face or edge path which surrounds the object, and then make an extrude, and I can use, let's see, offset in this case. So you see, it just offsets the extrude around the entire edge path. So effectively, that leaves me then with, I can look at this as a creasing edge, which will be internal to the actual contour. And then in object mode, again, just do extrude, and this time we'll use thickness. Thickness is very similar to actually just dragging in the local Z axis, so just dragging up from the, you see, it's very similar. But the thickness can actually sometimes retain more of a uniform thickness. So if I wanted to do something like that. And I could also do a couple of edge loops like here if I want to retain that. And here. And then subdivide it. So you have a very wacky shape, but I'm retaining a very uniform thickness. And the creasing edges are just kind of elegantly placed. Well, not so much. That's wonky. I don't know how that happened. So if you're making some sort of, I don't know, crazy kind of designer furniture, or so the whole point there is you could start from planes, start from planar models. And so I'm not going to spend too much time on this, but let's say so you're going to be building like knives and spoons and things like that. So if I just start shaping out more, you can have like reference images of a spoon or whatever. You can also start with a sphere in one end and then extrude, and then you have sort of the base for the spoon. There are several different ways you can approach building anything. But I do want you to sometimes just try to build something manually. Just start out and just extrude edges from a plane and see what you can get. Because I think it's a very helpful exercise. Because you're not relying on like, oh, I have to use this primitive or I have to like combine these things or whatever. You are able to sometimes just manually achieve anything. So here, I'm kind of, okay, so I'm looking at the spoon from the top, whatever, just kind of roughing in that shape. I don't care too much about the aesthetics, just want to quickly that, and then I can obviously always, if I grab this and scale to get that right. And there are several different topological, the placement of the edges is the topology, right? So the edge flow or the topological solution to the model could be, there's an infinite number of possibilities. And it's hard sometimes to say, well, this is the wrong topology or this is the right topology. You can sort of have a varying topology. Again, what you don't want to see are unhappy polys. See, the vertices are kind of stretched too far, or you kind of develop kind of a feeling for this, right? So we're dealing with quads. Everything is quads. We're just building it up, and we're keeping the edge flow more or less consistent. Not to say that you have to arrive at, maybe your topology will be kind of messy, and that's okay. Starting out, whatever. Just try things. And okay, do we have a dividing line there yet? No, so I always want a dividing line in whatever I'm building. So I would do an edge loop, So let's see. Maybe there's a way to snap this initially. I don't know. Probably. Really? Didn't work. Nope. I think there's a way, like if you set it to multiple and one. Yeah. So if you go to the tool settings, you can set the tool to multiple and one. That will insert the edge loop like in the mathematical center between each vertex point. In this case, it works because it's a perfectly symmetrical object. If it weren't, yeah, you could use different tools, but I could just go like this and say two vertices. Whoops. Essentially, just make sure this is 0x. Right. And then maybe to define this top one, I could then start extruding these guys inward. So extrude, and then thickness, or no, offset. Push that down. So gradually building this. And here I could do the, again, the same trick where I double click the outer edge loop. Let me just maybe make a little bit more. You get the idea. This is, so I'm not dealing with the thickness. I'm only dealing with the initial curvature. And maybe also, here it would be helpful maybe to have some references, but I don't really know what this should be. But, there would be kind of a curvature probably going this way. So just establishing that curvature in a completely flat version. And then I could do double click the outer edge loop and then extrude that out using offset. Again, that gives me that nice little defining edge all the way around. And then now I can extrude it in object mode and push it up a little bit. And I try to subdivide it or something like that. So obviously I would have to go in, tweak, tweak, tweak. And now push vertices around, like make things like, okay, so this, kind of, you want happy polys. The edge flow is flowing nicely. This is only one solution. It's not the solution how to make a spoon. You're just sort of, yeah, I built this from whatever. So if I wanted to tweak the, curvature, obviously now it's more, I can do it. Yes, no problem. I can definitely just grab this. And the thing is, I might start introducing some, it's a little bit less elegant. I might start, especially here. Like if I wanted to tweak this, which I probably do, I don't want it flat under there. Then I have thickness there. So I would have to deal with both of those at once. It would be much easier if I could do that, again, from the beginning stage where I only had this flat version. Does that make sense? Then I'd rather revert. I would go back now. I would go, no, actually I was not done. I would go back. See if I can convert that to faces. Oh, crap, I didn't select everything. So anyways, so select. Okay, let me just select this. Questions? I would revert to this and then keep tweaking it. So maybe, oh, you need to go away. Then maybe I need some more polys in here. And again, maybe I can, from the top view, maybe this is messy, I don't know. Here I could work symmetrically, so I can turn on symmetry on the move tool. So you hold W and then you click the left mouse button, hold. Maybe something like that. And now I can push these guys down a little bit. Right, something like that. So I'm just gradually making this thing, making the vertices behave the way I want, right? So subdivide that, it looks kind of like that. Maybe even more. Yeah, so this is it. You'll be spending a lot of time working with the vertices, kind of tweaking. But the more elegant you can start out, the better, right? So this takes a little bit of time getting used to. Like, what's the most elegant solution? And I think you'll find you'll get lost. Then my recommendation is always then maybe just start over. Just try again. because you can find yourself like working too much with a mesh. Like it can become too heavy or too complex, and it's like if you find yourself struggling too much with a single mesh like this, I'd rather see if you can start over, like from the simple, and try to find a more simple solution. So here, anyways, yeah, maybe that's more to my liking. Or I could go and select these vertices, like, and scale them apart, maybe. I don't know. Maybe I can grab these edges and pull them down a little bit. Try to subdivide that. Okay, so I would copy this object. So I would like keep it over here. Oops. So I treat this as my workbench. I would just copy things when I'm happy with that initial shape and I'm moving along. And again, I can then select the entire outer face edge path and then extrude and do a little bit of offset. Don't have to do that, but certainly an option. And then go to object mode and extrude the whole thing. And this would be a technically kind of solid model. I mean, okay, good model. It would be manifold. All the vertices are merged. If we go in here and take a look, it should have like thickness throughout. So, you know, we can look inside the model and see there's thickness. If there would be no thickness in here, like even in this, it's a tiny little area, but it does have a thickness. In other words, it has volume. There's something there. If you only had a plane, it doesn't really exist. It only exists in Maya, but it has virtually no volume. You couldn't 3D print it, for instance. I always kind of look at that as a measure of if it's a good model, because if it's manifold and you have volume and everything's kind of okay, then yeah, you could 3D print it, and that, you know, that there would be actual volume there. Yeah, it's not beautiful, but there you go. So then when you'd have to tweak it. It is helpful to look at references. Maybe something more like that. So another approach to this, and by all means, like if you want to experiment and find the more elegant solutions, maybe you could, you know, initially start out with a sphere, or even like a cube. Yeah. Okay. So topologically, there's a little bit of a difference, like from the. This is the sphere primitive in Maya. You probably made one. And you can see this is the topological solution you get. It's just like everything comes to a single vertex point, and you get all these tries. So technically it's okay, but it's maybe not the most beneficial topology. But if I smooth this, you can see this is a different topological solution. It's not a single point to which all the edges join, or it's a different solution. So you know, I could start up with this, and I could scale this, and I could go like that, and I could delete the top half, and that could be sort of the basis for my spoon. Certainly. And then maybe I'll just go and grab this, and I could extrude. Oh, let me turn off symmetry. Right, so you get the idea. So that could be the basis. It's just I'm starting off with this. And now I'm off to just building it whichever way I want. Again, looking from the top, defining that curvature. So defining the curvature this way, and then defining the curvature also in the profile. Kind of get used to observing this from different angles. Questions? Oops. questions? So then, yeah, I can grab all these vertices and still scale them, right? Grab whole sections of vertices, scale the vertices. I could make something like that. Yeah, yeah, let's make a frying pan. Beautiful. And we can. So just getting used to like, you know, scaling large chunks of vertices. Yeah. Extrude this entire thing in object mode. And there's your frying pan. Beautiful, beautiful. We can introduce. How can we retain this curvature a little bit more? Maybe I'll need an edge loop there and there. Oops, there and there. Now we'll have more of a sharp curvature. Not pretty. But I can grab all these words again. Scale. See that? Beautiful. So even if you had like more objects, some of you tried this, so will be the last thing we mentioned today. I think some of you tried the lattice. It's a very useful little tool. So if I copied the entire thing. So let's say I just want whatever. What's on a frying? Maybe some strange thing. It has a handle or something. Question? Yeah, if you want. You mean if you want to start out every model in a new Maya project, for instance? Yeah, you could do that. You don't have to, but you can. It's an option. I mean, the only reason would be if your scene is very, very large and you want to start off fresh. So there could be benefits to that, but I think for what it is, depending on the complexity of your scene. But I think you'd be okay. I mean, you just have to, you can hide stuff away, you know, in the outliner. Just select things, Control H, and they're gone. And then Shift H to make them reappear. So yeah, or you can just start off a new Maya scene and then literally import the Maya scene into a new Maya scene. That also works. Yep. Yeah. Yeah. So if it's only the geometry, so it's probably OBJ. It's just an old school nice format. If it's only the geometry and UVs you're exporting, then I'd recommend the OBJ. So export selection, and you just select OBJ. Here. Yeah, it has the object, and it also will export the normal information. So if you have some smooth normals or things like that, or yeah, and the UVs, which are kind of it's a part of the mesh sort of. No, that will not include materials and so forth. It's just the geometry. So that's OBJ export. It just stands for object. And that's like yeah, Blender wherever you want to send it. Oh, okay. So let's make a lid. Maybe then that's something like we could do. How can I make a lid? Any suggestions? No suggestions? Yes. Huh? Copy and flip and mirror and I'm lost. Yeah, copy and flip. Yeah, whatever. Yeah, you know. So experiment here. Maybe I could like use. Maybe I can use these and then I'll flatten them. That could work. So I select those in there. This is a bit like, and then grow that selection. Oh, Shift and the little button next to Shift, which has the larger than, or what do you call that button? The larger than or smaller than symbol. I don't know the correct name. Shift and the button right next to the shift there on the left side. So maybe I can do that, and then a shift select to invert, and then delete. And then maybe I could grab that, and I'll go center pivot. And then I'll scale it like that. And then I'll put it there. And then I'll extrude. Whoops, wrong button. And there's the lid. What's happening now? There's, yeah, more or less. There, perfect. And then maybe I want to add a little like handle there, so I could go and take these and extrude and just do offset. Maybe we could do circularize. Do like that. That's a nice new feature. So, oh, there's another little, there's an artifact. Let's just pretend that didn't happen. Oh no, too late. Let's just crap. So this is the thing, I see that something happened in there. So this will always happen to you, and it does happen to everyone. So this is what you want to have happen, right? It's all about failure, which is a good thing, because then you can address it. See, okay, so I see what happened. I had this selected when I was doing the initial extrude up here. I had this little face selected, so it also got extruded. So I have to now just delete that. Take a look in here, it looks okay. And then I will delete history and freeze transformations and mirror. Now it should be okay. You go down there. Oh no, okay, see. Yeah. And then maybe I can, yeah, so that's the thing when you're selecting faces. Maybe it's a nice habit also to go to wireframe. You can sort of see, just make sure you don't have additional polys selected, because that can happen. And then, yeah, whatever, you get the idea here. Whoa, that's a nice handle. How does a handle work? It needs to be actual handle. I don't know, whatever. So yeah, whoa, that's pretty. And then, thank you, too kind. So maybe then I'd probably go in here and I'd probably make that little top thing that it might be made out of like, I don't know, some other material which would not be heat conducing, and then, you know, that would be a separate object. And that would be nice, because then you're adding levels of detail and it will look very convincing. So those little things that you keep adding, that's really what makes the realism. Because, wow, it looks very intricate, like those little things. The whole point here was that I wanted to show the last thing we're going to talk about, which is the lattice, which is very quick. So the lattice deformer is just a very handy deformer if you have multiple objects and you still want to like tweak the shapes. Okay, then we make a lattice. This is a lattice. There's the lattice, and it has different divisions. So there, you know, we can use several divisions that way. And these work like vertices, except they're lattice points. So lattice point, and I can like drag these lattice points, and it will manipulate all the objects in there. And this is actually an animation deformer, which makes sense, right? If you envision kind of a cartoony, wacky character or something, and it needs to deform, but it has multiple objects and they all need to deform. This is how you do that. And so this would be sort of built into the rig, you know. So then, whoa, it could deform, essentially. But it's also very, very useful for modeling, which is why they've now added a lot of deformers here. Before we used to have to need to go into the animation thing here, but now it's under modeling, and it is very useful. So I'd recommend just check out some deformers. The lattice is the most useful, I think, because you can quickly change your mind, even if you have multiple objects. That's nice. Yeah. Now, how do we get rid of the lattice? Huh? Yes. When in doubt, delete history. There we go. Now it's gone. It has no connection to the lattice. It is gone. And we are happy. Okay. So the first, the VFX group, you run the lab in like half an hour or 40 minutes. And then the other group, games, you'll be there from, what is it, 6:30. Okay. And I would urge you to then today practice these kinds of things where you also start from a plane, you know, whatever. And then next week we'll build something like the teapot, which would require a little bit more attention. Yeah. Okay. See you in 40 minutes, the first group, and then 6:30 for the other group.